You're probably wondering how we got here. I was all set to start at the Core League University this fall when everything changed. My dad, Captain Gilbert, fell seriously ill and recovery has been tough. He's not just my dad, though. He was a deep current courier, a respected transporter of news, supplies, and messages across the ocean. I'm not here to scare you or to drown you in sorrow. I'm here to explain what happened to my dad and how we can make sure stories like his don't keep happening. Our story begins long before I was born. Back in the 1930s, scientists developed a group of chemicals called PFAS, short for per- and polyfluoroalkyl substances. What are PFAS? Simply put, they're a group of human-made chemicals that have a water-loving head and a water and oil-repelling tail. This special combo makes PFAS nearly indestructible. Once people on land discovered how durable PFAS were, they started using them everywhere. In nonstick cookware, waterproof jackets, takeout containers, firefighting foams, and industrial products galore. DuPont led early production, but soon PFAS were showing up in cleaning products, wires, pipes, semiconductors, hydraulic fluids, you name it. Why? Because these chemicals made a lot of money. Even though only 6 major industries really cash in on PFAS, their products can reach up to $360 billion from just one industry alone. In total, PFAS-based products make up nearly 4% of the entire U.S. GDP. They sound important, right? But even if we wanted to get rid of them, it's no easy task. It could cost an estimated $7 quadrillion every year to clean up PFAS at the same rate it's released into the environment. It didn't take long for the darker side of PFAS to surface. Not long after mass production began, scientists started raising red flags. Companies discovered PFAS were highly toxic. People with high exposure, especially factory workers and nearby communities, began getting sick. Cancer, infertility, birth defects, the list kept growing. The real kicker, PFAS don't just pass through your system. Because they're so stable, they bioaccumulate, especially in the liver and kidneys. They build up over time, staying in our bodies and in the environment. You'd think this discovery would have made companies stop, but instead, production ramped up and profits won out. And after these products are made, the toxic waste has to go somewhere. Waste from PFAS production typically gets sent to treatment plants. These facilities try to destroy them using high-heat incineration, which is the only known way to break PFAS' strong chemical bonds. But even that has problems. Burning PFAS creates a ton of CO2, and worse, it can lead to the formation of new toxic compounds. And believe it or not, this is the best-case scenario. To save money, some companies skip incineration entirely and just dump the waste into landfills. That pollution seeps into the soil, into groundwater, and often right into nearby rivers and oceans. And it's not just factories. Everyday products that contain PFAS, like old pans or cosmetics, can leach chemicals long after they're thrown away. And some people still see the ocean as their personal garbage bin. The result, fish like me are swimming in toxic soup. PFAS travel far. They move through water, seep through soil, and even catch a ride on airborne particles. They've even been found as far as Antarctica. My dad, his job took him through it all. Coastal waters, deep sea lanes, estuaries, and industrial zones. Those were the worst. Fish like us actually build up more PFAS than the water around us. Thanks to bioaccumulation and biomagnification, our levels only increase over time. One study in southeast Michigan actually found PFAS in 100% of fish tested. The highest concentrations were in the organs, where PFAS love to linger. If PFAS are this dangerous, what's being done about it? Governments have started to step up. Back in the 1960s, researchers noticed PFAS showing up in animals and in us. In 1998, the company 3M alerted the U.S. Environmental Protection Agency about widespread PFAS contamination. That moment sparked the first real moves toward regulation. By 2016, the EPA issued drinking water advisories, recommending just 70 parts per trillion. Since then, efforts have grown. The European Union is now working to restrict over 10,000 PFAS types. Several U.S. states have banned their use in food packaging, firefighting foam, cosmetics, and more. What about alternatives? The good news is, scientists and engineers are working on it. New substitutes are being developed that break down faster and don't stick around in our bodies or the ocean. Some companies are even voluntarily switching to biodegradable, non-toxic materials. With global action, smart innovation, and enough awareness, then maybe, just maybe, My dad can be the last sick fish.